open or unbiased diode. There is no external voltage applied here in this diode. This is P region and this is N region. We know that holes are the majority charge carriers in P region and electrons are the minority charge carriers, whereas in N region, electrons are the majority charge carriers and holes are the minority charge carriers. Now, these electrons from this N region, they enter P region across this P-N junction. Now, as soon as these electrons see the hole in the P region, they get attracted and recombine with the hole near the P-N junction. Now, for each electron which is diffusing into the P region across the junction, a positive charge is created in the N region near the junction and a negative charge is created near the junction in the P region. These positive and negative charges are forming depletion layer. So this open or unbiased diode has a depletion layer at the P-N junction. Now these ions in this depletion layer, they produce a barrier potential. Now what is this barrier potential? It is the potential which diffusing carriers of both types must surmount in going from one side of the junction to the another side. Now at room temperature, this barrier potential is approximately 0.7 volts for a silicon diode and 0.3 volts for a germanium diode. Now, in an open or unbiased diode, an electric field is set up across the depletion layer between the N-type and P-type material, and the direction of this electric field is from N region to P region.